Hello and welcome. Well, we have a problem here, and that is to integrate the expression x by 2 minus x to the power of 5 with respect to x from x equals 1 to x equals 2. So I really should actually rewrite this as the integral from x equals 1 to x equals 2 to be a little bit clearer, of x by 2 minus x to the fifth with respect to x. As with any typical math problem, there are several ways to find the solution. There are several methods of integration I could use. I could expand this expression out into a polynomial and integrate it, but that would require quite a bit of work. I could integrate by parts, but then again that's more work than what I have to do. So being a lazy mathematician, I think the easiest and most foolproof way to integrate this is to use the method of integration by substitution, or it's also known as u-Substitution. So let's choose to substitute u for our expression inside the brackets here. We're going to let u equals 2 minus x. So if we let u equals 2 minus x, and we're going to transform this from an integration with respect to x to an integration with respect to u. So we're going to have to redefine our bounds as well. So we're going from the bounds of x equals 1 to x equals 2. Now u is actually a function of x, so when x equals 1, u is equal to 2 minus 1, which equals 1. And when x equals 2, u is equal to 2 minus 2, which equals 0. Now, as I said, we've got to transform this from an integral with respect to x to an integral with respect to u. So we've got to find an expression for dx. And we do that by differentiating our expression for u with respect to x. So du dx is equal to -1. So that means du can be expressed as negative dx, and that means dx is equal to negative of du. And since u is equal to 2 minus x, that implies then that x is equal to 2 minus u if I rearrange this equation. So explaining this again. So to explain this a bit more clearly, we are substituting u for 2 minus x, and we are substituting x for 2 minus u. Okay, so that looks a bit messy, so I'm going to write that again down here. Scroll down a little bit. So the integral of x equals 1 to x equals 2 of x multiplied by 2 minus x to the fifth dx is now equal to the integral of when x equals 1, u is equal to 1, and when x equals 2, u is equal to 0. So I should say u is equal to 1 and u is equal to 0 of 2 minus u times u to the fifth times negative du. I could write that a bit clearer by taking the negative out the front, so we'll end up with 1 to 0. of 2 minus u to the 5th du. Now I'm going to switch the bounds upside down because it makes more sense to integrate from the lower bound to the higher bound rather than from a negative of the higher bound to the lower bound. So this can actually be rewritten as positive of the integral from 0 to 1 of 2 minus u to the 5th du. And we can actually expand this u to the 5th term inside the brackets to make it even easier to integrate now. So doing that will yield us the integral from 0 to 1 of 2 times u to the 5th minus u to the 6th du. And this will result in 2 times u to the 6th on 6 minus u to the 7th on 7 bounded by 0 and 1. So now it's a matter of evaluating when u is equal to 1 minus when u is equal to 0. So 1 to the 6th on 3 minus 1 to the 7th on 7 minus minus 0 to the 6th on 3 minus 0 to the 7th on 7. We can see straight away that this goes to 0. So we're left with 1/3 minus 1/7, which can be expressed as 7 minus 3 over a common denominator of 21, which makes it 4 over 21. Okay, that's one example of how you would use integration by substitution for a definite integral. If this video has been helpful, please give me a thumbs up. If you are a math student, please feel free to subscribe for future videos that may help you on assignments or exams. If you have any question that you would like me to do a video on, please feel free to comment on any of the videos that you've seen. Thanks for watching, and I hope you learned something.